Assalamu alaikum. Welcome back to our channel, Pakistan Zindabad, the next world superpower. Today, we are strapping in for a really critical mission, one that redefines the very meaning of military power.
And we should say right at the top, for everyone listening, this deep dive is based entirely on the analysis in Chapter 1 of the book Resilient Defense Pakistan in the Next War Doctrine, which was written by Mr. Zaheer Ahmad Meer.
Absolutely. And it's a vital piece of work. We're talking about nothing less than the fundamental way that nations measure strength and, how they wage conflict.
It provides a very sober look at how defense, doctrine, and technology have to converge in what the source calls the critical AI era, which is roughly now 2026 through 2036.
So if you thought national security was still about, counting tanks and measuring the flight range of your best fighter jet, we are about to pull back the curtain on a revolutionary transformation.
A total shift.
The battlefield has gone invisible,
Right.
And the war is now being fought primarily at the speed of thought.
Exactly. And the mission for you, the listener, is to unpack this central argument that the nature of war has fundamentally shifted. It's moved away from physical platforms.
The big expensive hardware we all think of, right? The tanks, the ships.
Yes, all of that. And it's moved toward these invisible, interconnected, integrated systems, and most crucially, the speed and the quality of decision-making.
And we're not talking about some slow, gradual change here. The source argues this is a paradigm collapse, a complete breakdown of the old way of thinking.
It is. It's a shift where the metric of strength is no longer just platform quantity or having the most advanced tech in one single machine. It's about systemic resilience, integration, and cognitive speed.
We're moving from industrial age warfare to information age warfare.
And the institutions that fail to make that transition, well, they risk catastrophic strategic failure. It's that serious.
So the core question we have to answer today is essential. If national strength is no longer measured by physical hardware, what is the new decisive measure of military effectiveness? We have to understand the crumbling foundation before we can build the new structure.
A good place to start is where the source begins defining the old era that's now collapsing under the weight of new technology.
Let's do it. For over a century, military power was really defined by the legacy of the industrial age. When we thought about a powerful nation, we pictured overwhelming numbers.
Mass-produced, durable, very expensive hardware, naval tonnage, the number of artillery tubes, the thickness of tank armor.
And the quality of the crew operating those platforms, that was the whole game.
That's absolutely right. The source clearly identifies this as the platform-centric model. And this wasn't just a military idea. It shaped geopolitics, economic policy, public perception, everything.
So for centuries, if you wanted to measure a nation's ability to project force, you basically you tallied up its physical inventory.
You did. And the entire defense establishment, from procurement cycles that lasted decades, to training regimens, to doctrinal thinking, everything was shaped by this industrial model where security was quantified by the number of platforms, the tech inside that one platform, and how good the crew was.
It rewarded mass, durability, and this sort of slow, incremental, high-cost perfection.
And, it created a very satisfying, almost tangible measure of power. You could stand next to a new aircraft carrier or the latest fighter jet and say, that's why we're dominant. That machine right there gives us the edge.
But the source argues pretty compellingly that this entire model isn't just stagnating, it's fundamentally failing. The costs just don't justify the vulnerability anymore.
Especially when facing these low-cost, integrated threats. The model is, functionally reaching its strategic limit. The analysis here is sharp. Wars are no longer decided by the mere possession of individual weapons platforms.
Even if they are hyper-advanced, fifth-generation assets.
It doesn't matter. The inherent value of that single, immensely expensive platform is being diluted so rapidly by digital threats and cheap systems that the old logic, where we chase maximum perfection in one object, is becoming strategically unsound.
Okay, so this is where we get into the systemic breakdown, because the critique goes way beyond just the hardware itself. It's targeting the entire logic that governed warfare for the last 100 years. Let's look at the 4 bedrock assumptions of that industrial age logic that the source says are now defunct.
And these assumptions were treated almost like laws of physics, immutable truths. They dictated resource allocation and strategy all over the world.
Okay, the first assumption was pretty straightforward, very intuitive. Platforms are decisive. The idea was simple. Superior hardware, the better tank, the faster jet, the more precise missile guarantees dominance.
You win by having the best machine.
Simple as that.
And that, logically led to those enormous decades-long procurement cycles, all focused on achieving maximum perfection and durability in that single piece of hardware, often at astronomical costs. If that platform was invulnerable, you won.
But the source is arguing that invulnerability is now just an illusion.
Completely.
All right, the second assumption was about structure and tempo. Control is hierarchical. Information flows up through the ranks, gets processed by senior leadership, and the decisions flow slowly, methodically back down.
The classic military chain of command. It emphasizes stability, clear lines of authority, and it was designed for a war fought at a human speed.
It fundamentally assumes that the person at the top has time.
Time. Days, hours, at least a substantial amount of it, to synthesize all the information that takes time to collect and transmit up the chain. This whole assumption is built on a slower operational tempo, a luxury that just doesn't exist in the AI era.
Not when engagement times are measured in seconds or even milliseconds. The third assumption, and this is the one that the source highlights as maybe the most dangerous strategic vulnerability today, was that communications are assumed.
Right. Command and control, or C2, the ability to direct and synchronize your forces and navigation systems like GPS, they were all treated as reliable constants.
So you bought the hardware just assuming the network, the GPS signal, the satellite link.
Yeah.
It would all just be there to enable it.
It was an unspoken operational luxury. When you designed an operation, you designed it assuming the radio would work, the GPS would be accurate, and the sat link would hold. The source stresses that this assumption of guaranteed connectivity is now the single most dangerous vulnerability.
Because it's become the main target.
The primary target for any serious adversary.
And finally, the fourth pillar, which defined the nature of conflict itself. Wars are episodic. Competition, meaning deterrence, positioning, influence campaigns, was seen as clearly separate from conflict.
There were bright, visible thresholds, right? Crossing a border, a formal declaration of war. You knew exactly when the war started, and you had a clear idea of when it ended.
These four assumptions shaped everything, even how training was done. Forces trained mostly on operating platforms under ideal conditions.
Under non-contested conditions, which is the key.
Yeah.
But the AI-enabled battlefield is ruthlessly dismantling every single one of these spellers all at the same time.
Okay, let's get into the specifics of that. Let's turn to the analysis in the source. How are these four pillars actually being dismantled in practice? This is where the cost-benefit analysis of the old model really just falls apart.
The undermining is happening on multiple integrated fronts, and often it's non-kinetic, which is the key strategic shift here. Let's start with the economic challenge, the low-cost threat.
Drones.
Drones are the perfect example. We're seeing low-cost unmanned aerial systems, sometimes just modified commercial drones or mass-produced small ones that can neutralize extremely high-value platforms.
I mean, we've all seen the videos. A simple, maybe $5,000 drone strike renders a multi-million-dollar piece of hardware or critical infrastructure useless.
Temporarily inert or permanently destroyed. This forces a massive and immediate reassessment of defense economics. It's a game changer.
And that's the critical point for our listeners who follow defense spending. Why spend billions on one fifth-generation jet if it can be taken out by a coordinated swarm attack that costs just thousands of dollars?
The quantitative superiority of hardware is no longer the guaranteed differentiator. The cost-effectiveness of the other side's low-cost integrated systems fundamentally erases that advantage. The cost-exchange ratio is now wildly unfavorable to the owner of the big, expensive platform.
Okay, so that's the economic angle. What about the other assumptions? Hierarchical control and reliable communications.
Right. So the existential threat here is the non-kinetic attack. We're talking about electronic warfare, or EW. It's specifically designed to degrade communications, jam sensors, spoof navigation systems, disrupt radar.
And all that firing a single bullet.
Exactly. Without a single kinetic round. It's almost a philosophical attack, isn't it? The difference between destroying something and just making it entirely irrelevant by taking away its ability to see or communicate or think.
You've basically neutered a sophisticated platform or a whole unit just by attacking its nervous system.
That's a great way to put it. The tank is still operational, the plane is still flying, but they're blind, they're isolated, and they can't coordinate with the larger fight. This breaks the assumption of reliable communications, and it completely paralyzes that slow, hierarchical C2 structure.
And then there's the blurring of the line between peace and war, the end of that episodic assumption.
That's driven by cyber preemption. Cyber operations and information warfare, they don't wait for a formal declaration of conflict. They are designed to disrupt logistics, degrade critical national infrastructure, fracture public trust, and compromise command systems before any kinetic conflict is formally acknowledged.
It's war below the traditional threshold.
War, in this sense, has become a constant state of competition. It's a digital engagement waged 204/7. Cyber operations establish dominance and vulnerabilities that will be exploited when the kinetic phase begins. They are pre-positioning the battlefield.
So that brings us to the critical conclusion of this section. If all four of these industrial pillars are crumbling, what happens to the hardware, the platforms themselves?
The source summarizes this perfectly, and this is the vital takeaway for everyone listening. The result is not that platforms become completely obsolete. They still exist, they still carry payloads, they perform vital functions. But they are definitively subordinated to the systems that connect, enable, and sustain them. They are no longer the center of gravity. They are just kinetic components in a larger, far more crucial digital architecture.
So we've established that the platforms have taken a backseat.
Yeah.
Okay, let's move to section 2 and define what they are now serving. If we are truly moving into what the source calls system of systems warfare, what does this new contest of power look like, and how do you measure success?
Modern conflict is now fundamentally a contest between entire integrated architectures. Let's try analogy to simplify this. In the industrial age, a military force was like a collection of highly specialized, high-performance sports cars, each one operating independently, relying on a single human driver.
Okay, I'm with you.
In the AI era, the force is more like an integrated modern smart city. Everything is interconnected, the traffic lights, the power grid, the emergency services, the navigation apps, all feeding into a central neural network. You don't defeat the city by disabling one car.
You defeat it by crippling its power grid or its data network.
Exactly. We're no longer talking about tank versus tank. We're talking about sensor network AI effector architecture A versus sensor network AI effector architecture B.
So what's the decisive factor in this new contest? What defines the winner?
The source is crystal clear on this. The decisive advantage belongs to the side that can sense faster, decide faster, adapt faster, and remain functional under disruption.
Speed and resilience.
They are paramount. If you are 2 steps ahead on the decision cycle, what military planners often call the ODO loop, the physical hardware of your adversary, no matter how good it is, simply cannot react in time. It's a fundamental cognitive advantage that translates digital speed into physical effect.
Let's detail the components that make up this nervous system. This is the heart of the new system of systems architecture. The source talks about connecting 5 essential elements that have to fuse together seamlessly.
Right. The architecture starts with the inputs, sensors. And these are diverse and pervasive. We're talking space-based satellites, high-altitude or low-orbit aerial drones, terrestrial ground systems.
And crucially, cyber inputs. The data coming from the informational domain.
Yes, the sheer volume of data is just enormous, which is where the next element becomes so critical.
Which is the data pipelines. And this is, you could argue, the most important element for a nation trying to gain an edge. This is where all that raw sensory input, which is often just noise, gets fused into actionable awareness.
This is the AI and machine learning component. It takes a massive stream of noise, 1 million data points per second, and instantly turns it into coherent, relevant understanding for a human or an automated decision maker.
It's the difference between knowing 1,000 things are happening and knowing the one thing that matters most right now.
Precisely. Then we move to the decision processes themselves. These are increasingly supported by automation and AI. This is where the system determines what the fused data means, what the risk profile is, and what action should be taken, often without human intervention in high-tempo situations. This is where the speed advantage is truly generated.
And of course, none of this works without the communications networks. These are the digital arteries connecting every single unit, from the strategic commander thousands of miles away to the tactical effector on the ground.
Across all domains: land, air, sea, space, and cyber. If those pipes get clogged, the entire system fails.
And finally, we have the effectors, the actions taken based on the decision.
And critically, the source specifies that these effectors can be both kinetic like a missile or a shell fired by a platform which is now subordinated.
And non-kinetic.
And non-kinetic. An electronic warfare strike, a cyber denial operation, or a precision disinformation campaign. The physical hardware, the platform, is now just one type of tool available to the system.
What's truly fascinating is that the destruction of a single platform, that expensive industrial age asset, it rarely decides the outcome anymore. What determines success or failure, the source emphasizes, is whether the overall system can continue to function when parts of it are degraded or disrupted or destroyed.
And that defines the new center of gravity in AI-era conflict. Decision superiority. This isn't just about speed. It's about robust, sustained operational coherence under pressure.
We need to define decision superiority carefully, though. The old idea was just about making a fast choice, but the source gives it this vital strategic depth that includes coping with inevitable failure and pervasive uncertainty.
Absolutely. Decision superiority is the ability of the command structure and its supporting systems to sustain effective, coherent operations under extreme stress. The source centers it around four pillars that have to be mastered at the same time.
Let's walk through them. Number one, the ability to maintain situational awareness despite disruption.
This is the resilience test for your sensor system. If your primary high-bandwidth satellite link is jammed by an adversary, can the system automatically switch to a low Earth orbit mesh network or a terrestrial fiber backup, or even use old-school low-bandwidth communications without skipping a beat?
The system needs redundancy built into its ability to see.
Exactly. Number two, the ability to prioritize correctly under uncertainty. When the adversary is using sophisticated misinformation, generating digital noise, or masking their true intent, the system has to filter that noise.
Often using advanced AI correlation.
Right, to focus resources immediately on the most critical threat. And this requires not just fast algorithms, but profound doctrinal clarity about what acceptable risk looks like. If you fail here, you're just wasting expensive assets attacking ghost targets.
Number three, the ability to act coherently across multiple domains. This is the integration test. This means the decision made in the cyber domain, say taking down an enemy power grid, has to instantly inform and synchronize with actions in the air domain.
Like diverting fighter jets based on that grid failure.
And all within seconds, all while respecting the overall strategic objective. You just can't have stovepipe domains anymore.
And number four, and this is maybe the most important, the ability to learn and adapt faster than the adversary. If the opponent changes their tactics, introduces a new countermeasure, or exploits a vulnerability in your system, your architecture has to incorporate that new data and modify its behavior or doctrine almost instantaneously.
In real time.
In real time. This immediate machine speed learning is the ultimate expression of AI integration. It's the hallmark of a truly resilient system.
So we've established that AI, data fusion, and automation are the engines of this superiority. But here's where the source gives us a really critical nuance, a warning against, technological determinism. Is faster always better, or can you just build a faster path to failure?
That warning is vital, especially for nations in the planning phase. These technologies, AI, fusion, automation, they only amplify the advantage when they are embedded within resilient institutional and doctrinal frameworks.
What does that mean in practice?
Well, consider this. If you just dump the most advanced AI onto an old, slow, hierarchical structure, you just end up with incredibly expensive complexity and highly brittle systems.
Yeah.
If the humans and the bureaucratic processes around the AI can't keep up with its suggested decision speed, or if they don't have the training to trust its automation, then the AI's advantage is completely wasted.
The bottleneck becomes institutional, not technological.
Precisely. This is a huge, challenging realization for any defense planner. The technology doesn't guarantee security or superiority. It's the organization that deploys it, the doctrine that guides it, and the training that supports it. That's what matters most. You have to change the culture to harvest the benefit of the chip.
Okay, let's pivot to what the source calls the most dangerous assumption inherited from the industrial age. We touched on it earlier, but Section 3 focuses entirely on connectivity as the most contested and vulnerable domain.
The dangerous assumption, born of decades of uncontested airwaves and reliable GPS, is the belief that connectivity will always be available. In previous eras, this was a reasonable planning assumption. Today, according to the source, it's the greatest strategic liability.
So building a complex, integrated system on the foundation of guaranteed connectivity is, to put it bluntly, inherently foolish.
It is, because the network is now actively and intentionally contested across all domains by every serious adversary. The source outlines several layers of degradation that make reliable communication impossible.
Okay, what are they? First, you have traditional electronic warfare, EW.
Right. This is jamming, spoofing, and overloading radio and radar signals. It's the constant static that prevents the message from getting through. Or worse, tricks the receiver into thinking the message came from an authorized source when it didn't.
Then you have the increasingly sophisticated cyber attacks. And these don't just target the network, but the integrity of the data itself.
That's the key difference. They don't just cut the line, they corrupt the data passing through the line. And that can lead to catastrophic misinterpretation or paralysis through sheer distrust of your own systems.
We also have physical threats against the space layer satellite disruption. This includes kinetic anti-satellite weapons, but also soft kill measures.
Like directed energy, blinding satellites, or simply crowding the spectrum used for satellite communications to drown out the signal.
And critically, there's pervasive spectrum congestion. Simply due to the sheer volume of civilian and military signals crowding the airwaves, reliable, clear communications are becoming harder and harder to achieve.
It demands far more sophisticated frequency hopping and filtering than ever before. So this isn't just one enemy attack. This is a systemic, multi-layered, simultaneous assault on the nervous system of your force across all domains, meant to cause complete disorientation.
And the operational risk that comes from this is, well, it's catastrophic.
It is. Forces that have built their entire doctrine, their training, their hardware around uninterrupted connectivity, which is what the old industrial model encouraged, they risk total paralysis when their networks inevitably fail or are degraded.
The expensive, powerful platform suddenly becomes an inert liability.
Just because it can no longer receive the decision it needs to act, or even worse, it acts on compromised data.
This leads us directly to the required mindset shift. The difference between designing for fragility and designing for resilience. We've seen many modern systems that look brilliant on paper but just collapse under the first sign of real pressure.
A defense posture built on the assumption of perfect connectivity is inherently fragile. When the coordinated EW and cyber attack inevitably comes, and the source assumes it will come and it will be coordinated, the system breaks down entirely. The strategic shift required is toward a resilient defense posture that accepts disruption as constant, expected, and systemic.
It's an intellectual acceptance of imperfection.
It is. It's a huge shift in philosophy. You stop trying to build a perfect, impenetrable wall, and you start designing systems that can bend, absorb damage, and continue operating effectively despite losing major components.
So the focus moves entirely to operating through degradation.
Exactly. Effective forces must be specifically designed from the ground up in hardware, software, and written doctrine to retain operational coherence and execute actions even under severe pressure when networks are degraded or completely denied. This means building in local autonomy, empowering decentralized decision makers, and relying on high redundancy, lower bandwidth comms systems as the default, not the backup.
Let me push back on that for a second, though. If you introduce more reliance on digital systems and AI for integration and speed, aren't you just replacing one form of fragility, the exposed platform, with another, even more vulnerable one, the digital network?
That's a critical point, and the source implicitly addresses it by mandating resilience in the doctrine. The goal isn't to create a perfectly connected system. The goal is to create a system that can gracefully shed layers of complexity when it's attacked.
So the platform still needs a core local ability to fight on its own if the network is completely gone.
Yes, absolutely. That's the required doctrinal resilience. But the systemic advantage comes from the ability of the overall force to continue synchronizing its efforts even when, say, 70% of the network is denied. If the industrial age platform was a standalone computer, the new system is a resilient, decentralized mesh network where failure in one node actually strengthens the surrounding nodes.
So if we synthesize this argument, resilience, not technological sophistication alone, is the defining attribute of effective defense in the AI era. It's not how advanced your components are in isolation.
It's how effectively the whole system functions when 30% or 50% of your sensors and communication links are offline. That is the heart of the matter. If a system collapses entirely under the first punch, if the loss of GPS means the entire Air Force is grounded, then it doesn't matter how smart the individual chips inside were. The system is a strategic failure. Resilience is the non-negotiable measure of success.
Now we need to contextualize this radical doctrinal shift. The source grounds its analysis in the specific, complex regional environment faced by nations operating in constrained environments. For a country facing geopolitical pressures and economic constraints, why is this shift from counting platforms to measuring systems a matter of national strategic survival?
The environment is incredibly demanding, especially in complex regions defined by rapid technological diffusion and intense rivalries. First, these nations are facing critically compressed decision timelines due to high-tempo crises.
Right. With modern precision weapons and integrated systems, the time you have to gather intelligence, synthesize it, and approve a response has shrunk from days or hours down to minutes or even seconds.
A slow, hierarchical, industrial-age decision model is simply too slow to survive the initial engagement. The adversary, using integrated systems, can achieve decisive effects before the legacy force can even confirm the threat.
Yeah, then there's the technology itself.
Secondly, there's the alarming rapid diffusion of dual-use technologies. Technologies like AI, drone swarm capabilities, and advanced cyber tools are quickly migrating from labs and commercial markets to adversarial states and even non-state actors.
Often outside traditional military channels.
Right. And this dramatically lowers the entry barrier for disruptive threats and makes maintaining a qualitative technological gap, which used to justify those expensive platforms, far harder and much shorter-lived.
Third, and this is maybe the most concerning in volatile regions, are the amplified escalation risks.
Because decisions are being automated and timelines are compressed, there's a much higher risk of misinterpretation, miscalculation, or unintentional escalation. When you remove human decision-making from key parts of the cycle, the sheer speed of the systems interaction makes conflicts inherently less stable and more likely to spiral out of control.
And finally, we have to address the reality: institutional and economic constraints.
Defense budgets are not limitless, especially for nations prioritizing internal development. Trying to match quantitative adversaries platform for platform is simply unsustainable and fiscally inefficient. The economic constraint demands systems integration and speed as an offset strategy. It's a non-negotiable path to maximizing your existing investment.
So this means systems thinking isn't just a doctrinal preference, it's an economic necessity. How exactly does this strategy offset quantitative disadvantages?
The source explains that systems thinking allows a state to maximize the effectiveness of existing, maybe even older platforms through superior integration and speed. Imagine you have a large inventory of older artillery pieces. In the industrial age, they were defined by their range and caliber.
Pretty simple.
In the AI era, if you connect that older artillery piece to cutting-edge space-based sensors, fuse that data with AI targeting algorithms, and give the crew a decision in 10 seconds instead of 10 minutes. Its effective capability can easily exceed a newer, unintegrated platform operated by a slower doctrine.
You offset quantitative disadvantage through qualitative superiority in processing, speed, and connectivity.
That is the primary strategic benefit. It lets you maximize the return on investment in existing hardware while buying crucial time and strategic space to develop next-gen effectors and doctrines.
And this requires a fundamental change in design philosophy.
A huge one. The principle must shift to systems that degrade gracefully rather than collapsing entirely under attack. We need to explore what graceful degradation really means. It's not just having a backup radio. It means the system is designed with multiple layers of redundancy in 3 critical areas: hardware, software, and doctrine.
Okay, let's break that down. What does that look like in practice? Hardware redundancy.
On the hardware side, it means diversification. If your GPS satellites are destroyed, your units must be able to instantly switch to inertial navigation, terrestrial beacons, or even optical and visual cues, perhaps processed by local AI.
And on the software side?
Decentralized processing. If the central command network is compromised, individual unit AI should have enough local processing power and preloaded doctrine to continue its mission autonomously without waiting for permission.
And doctrinally, that seems like the hardest part.
It is. Doctrinally, graceful degradation means empowering human leadership at lower echelons. It means training for mission command under conditions of total communications blackout. The soldiers are trained to execute the overall intent of the command, even if the real-time instructions stop flowing. The system doesn't go silent, it just reverts to a lower bandwidth, lower autonomy operational mode, but it continues to function coherently.
Which is the exact antithesis of the brittle, perfection-seeking industrial model that demands constant communication.
Right, but again, the source immediately pulls back from suggesting that technology is a silver bullet that solves all these problems automatically. We have to reiterate that key warning.
Technology alone does not produce security.
Exactly. What truly matters is how the technology is organized, governed, and operationalized within the doctrine and the institutions. Without the proper doctrine, AI just automates mistakes faster. It amplifies the rate of failure. Without institutional willingness to change the procurement cycle, new sensors will provide data that nobody is trained or authorized to use.
So recognizing the shift from platforms to systems is step 1. Step 2, and the subject of the source's concluding sections, is translating this systemic realization into a new defensive paradigm. They propose the concept of resilient defense.
Resilient defense is introduced as the unifying doctrinal response to AI-era warfare. It's an approach that accepts systemic disruption as inevitable and designs the entire apparatus, institutional and technological, around that inevitability. This is far more than a new piece of technology or a new jet.
It's a total re-engineering of the national security framework.
It is, and it demands institutional agility over bureaucratic rigidity. That requires massive reform across the entire defense establishment. The source identifies 4 critical areas where this change has to be operationalized.
Okay, what are they?
First, doctrine. This means explicitly prioritizing resilience over seeking perfection in any single platform or system. Doctrine has to mandate and reward mission success achieved under severely degraded conditions rather than assuming ideal scenarios. This means a fundamental rewrite of training manuals and wargaming scenarios to normalize chaos. Second, institutions. The source highlights the urgent need for speeding up the fielding of capability, what they call operational speed. The long, slow, bureaucratic procurement cycles designed for decades-long platform development can't possibly keep pace with the exponential speed of commercial AI and software development.
Institutions have to become agile enough to ingest and deploy critical, commercially developed capability in months, not years. Otherwise, the technology will be obsolete before it even hits the field.
Third is training. Forces must explicitly normalize and train for degraded operating conditions. Troops shouldn't just know how to use the high-tech connected systems. They must master operating when GPS is denied, when comms are intermittent, and when machine decision support algorithms are unavailable. Training has to be more demanding and more complex than any expected combat scenario.
And finally, innovation.
There have to be dedicated, secure, and rapid pipelines to connect civilian technology to defense needs. Since so much of the truly disruptive AI and sensor capability is being developed in the commercial sector, outside of traditional defense industries, the defense structure needs mechanisms to incorporate that innovation rapidly without all the usual bureaucratic friction that slows down adoption.
So those 4 areas, doctrine, institutions, training, and innovation, are the practical roadmap.
They are. They show that the future of defense is not just a technological challenge, but a profound organizational and doctrinal one. The organization has to be as fast and adaptable as the AI it commands.
Okay, let's bring this all back together for the listener. Our deep dive into Chapter 1 of Resilient Defense reveals a foundational, non-reversible shift in the character of conflict. The war is no longer won in the hardware inventory. The tanks, the jets, the ships.
The war is won in the data pipelines, the integration of sensors and effectors, and the resilience of the decision processes that connect them. The keys to victory are relentless integration and superior speed under disruption.
The critical takeaway for strategic planners, then, is this. A fundamental choice faces any nation today.
They can continue to adapt incrementally, essentially just strapping new AI systems onto an outdated industrial age skeleton. That's a path that leads to complexity without resilience.
More.
Or they can commit to a radical re-engineering of their entire defense posture, built from the ground up around the principles of resilience, integration, and decision superiority. The future belongs to the rapid, adaptable system, not the massive, slow, and expensive platform.
The analysis sets up the next critical question for planners beautifully. How does a state design security and allocate its scarce resources when disruption is no longer an exception to the rule, but the rule itself?
And that leads us to a final provocative thought that ties back to the low-cost threat we identified at the very start. If their new metric of military power is truly decision speed and operational resilience, and if low-cost systems can reliably neutralize high-value platforms,
then does this mean the traditional, incredibly expensive platforms of the industrial age will soon become primarily liabilities rather than assets?
it's a serious question. Because their slowness, their large physical footprint, and their high susceptibility to cheap systems disruption makes them too costly to lose and perhaps too slow to win.
Food for thought indeed. This analysis completely shifts how we have to think about national security investment. Thank you for joining us on this deep dive. We'll see you next time.